So I don't want to drag us down here, but I just wanted to kind of give you a sense of where we're headed and where it fits into the bigger picture as a way to kind of open it up to all of you. I think maybe we'll take a break, but before we do that, are there any questions before we lose Anirudh? Are there any questions that you would like to explore? We asked this question at the beginning, and we're going to go back to that. Should I do that now? Okay. Give me a second. We thought it would be interesting to just scroll through the questions that you asked at the beginning and reflect. How did we do? Did we cover the kinds of questions that you had? Would you be willing to help us with this? So this is what you told us. These are what you were hoping that you would take away from this workshop. Getting a sense of how user-friendly OpenQuake was, how to use the software, so how to build risk calculations, get a better sense of what's being done at different levels of government by different groups, academic, public, private sector, in the realm of earthquake risk modeling. See some comprehensive examples of how OpenQuake could be used to measure earthquake risk and risk reduction. An opportunity to share knowledge amongst us as a community of practice. What's kind of the current state of research in this field. You also gave us your feedback on what specific questions or topics you wanted us to address. And these were, hopefully we covered PSHA better. You could get a sense of what we're doing for the national PSHA model, what goes into it. That was a lot of what we heard. Getting a sense of how uncertainty is managed in both the hazard and risk calculations. We didn't quite get to untangling the strain related to post-glacial rebound. Components of a deterministic seismic hazard assessment. So I don't know if we covered the whole range of questions that you've had, and we're not going to ask you to redo this, but we thought we did think it would be kind of interesting if you're willing to go back to this question. And if you're willing, on your device or your laptop, if you were to sign into menti.com and use this code, how would you now rate your level of knowledge in these areas after the workshop? Has it changed at all? Are you in the same spot, or do you feel like you've moved the dial down the road a little bit in terms of your knowledge or capacity to work in this field? So I'm getting the sense that we're tired. We got one response, and that's fair. So this is cool. We were in kind of the 1.5 range for scenario-based hazard and risk assessment, and it looks like we've gained quite a lot of knowledge and comfort level in terms of the probabilistic modeling, which is something that we wanted to achieve in our first workshop in Vancouver, but we didn't quite get there. And in this workshop, I can tell you that your interest and where you kind of drove the work that we did here around probabilistic modeling kind of helped us to push the bar a little bit further than we were able to in the last workshop. So we really appreciate you giving us this feedback. I'll leave this open for those online or for anyone who might want to share your insights. But we take this as an indication that we're moving the bar a little bit but we understand that we're just a piece of this puzzle. So after the break, again, there's an open invitation for anyone who would like to share the work that you're doing relevant to this field that might help us build our collective knowledge and move us a little bit further down the road. So I think with that, on behalf of Anirudh and Catalina, and on behalf of our host, Western, the Good Vibrations and Excitations Laboratory, and the support that they provided us, the wonderfully generous support that they provided us here as part of the workshop. We'd like to thank you all. We'll take a break for coffee, but we would like you to come back and continue the conversation and share your knowledge with us. So thanks. Well done, everybody. And for those online, we will come back in maybe 15 minutes, and we will have at least, we know, one presentation, but possibly a few other, and we hope that you can stay with us.
Just stop the recording.
Yeah.
With this one. Just stop it. No, the pause. Yeah, it's.
Can you share your screen? No, you have to share your screen.
The Zoom.
Okay, so the screen and yes, or you can put it on your just
wait a couple of minutes.
series. No, I think people is listening to this. Okay.
Okay, so should I proceed? Okay. So good afternoon, everyone. This is the last presentation. We are not done yet. So it won't take long now. Maybe 10 minutes maximum. So I'm gonna present some of the effort that we are doing at the Geological Survey of Canada at the Quebec City office, and the work is mainly focused in developing an interactive web app for natural hazard risk assessment. So not just earthquakes, we're moving to work on floods and other natural hazards in partnership with other departments. So just to give you an overview why we initiated this project. So we looked at what are the public safety community needs. So they are interested in basically two aspects: emergency management, so real-time evaluation of negative impacts, and having what-if scenarios for their mitigation plan. So they are looking for a range of hazards with no or low delays, so something very rapid, with no or low costs, basically, and also something that is consistent, that is standardized along the multi-hazard aspects, and also something that can be updated on a regular basis with new knowledge, with new science, and also something that is accurate enough, so based on good science. So this is the rationale, actually, of having this tool, is we have several tools that exist in natural hazard risk assessment, but these tools are intended mainly for experts, small number of expert and technical users, so it cannot be used by anyone. You need to have very strong knowledge about seismology, for example, and structural engineering, geotechnical, and many years of experience. So for the emergency management community, it's very hard for them to even run this kind of simulation by themselves. So now we see that there is a communication gap, so we don't speak the same language. The technical and scientific community and experts are talking in a different language. There is no communication between the two end users, which are the public safety community and emergency manager, and between the technical specialists. So the main features of the ERP that I will make a demonstration in 2 minutes, that it's based on fundamental science. It's a homemade product. It's made here in Canada, and it's a one-stop shop for multi-hazard. So the interface is similar between you can run multi-hazard with the same interface, similar visualization. It's transparent, so the methodology itself is simple. It can be even replicated in spreadsheet solution if you would like to do this analysis by yourself. There is references and technical documentation, so you can do this and verify the results that you're seeing on the screen. And also, it's mainly used for first order screening tool. It's not intended for detailed seismic evaluation or looking into building by building. It gives a big picture, an overall idea of what would be the order of magnitude of seismic damage or losses. And it's mainly intended for a direct, make it easy for a non-expert user to communicate the risk. So the main three components that is standard for evaluation of earthquake risk. So you have the seismic hazard model, the inventory of assets based on census tract level, and we have the vulnerability or damage functions, which are standardized approach of calculating the damage. And these three input parameters or databases are on the background, on the back end side of the app. All these are integrated together, so you can run on the interface multi-level scenarios of different magnitude and distances from your study area, and you can see physical damage, economic loss, and social losses. So just to acknowledge that this project is supported by the Public Safety Geoscience Program at GSC Canada, and also funded by the Canadian Safety and Security Program in partnership with Public Safety Canada. So now I will move to the app itself, the demonstration. So everyone sees the screen? Okay. So I'm gonna just refresh the screen. Okay. So this is the landing page, just to give an idea what is the summary of the intent of the app and some simple instructions and a disclaimer of just to show that these are first order estimate, they are not exact results and order of magnitude. And then we can zoom into our study area. For example, I'm going to pick Quebec City, right next. And then I will click anywhere in the map. I can click, for example, here in downtown Quebec. And then I don't see the, okay, it's here. So I can choose the magnitude. For example, I'm going to pick magnitude 6 scenario. And then I would choose depth of 10 kilometers in average. And then I would simply just say run. So right now the calculations are done on the fly. So goes back to these three databases and integrate the ground motion prediction equation, calculate the shaking intensity, go to the inventory model, look at the building classes, calculate the damage using the fragility function for each building class, and then aggregate the results on a census tract, So it's going to take maybe 1 minute. So we can zoom in and out just to see the progress of the analysis. And typically it takes only 50 kilometers from the epicenter. So this is most probably the shaking intensity will start to decay and there will not be much damage. So we only consider the 50 kilometer range from the epicenter.
Similarly, uses surveys.
Sorry.
Household for the surveys.
Yes, it's user protected for now because it's under testing. Yeah. So it's almost done. So the analysis is now complete. We can click on the statistics report just to give a summary. For example, the total exposure for the around 200 census tract, around $100 billion. The total economic loss are $2 billion. This number should be approximated. Shouldn't be like 2.275 million. It should be like $2.5 billion. And the total number of buildings that are exposed to the shaking intensity, and the number of buildings that are in different damage state, in aggregate number. So the emergency manager would have an idea about how many buildings are extensively damaged, which are typically the yellow tag, or complete damage, which are red tag. Also the number of injuries and expected number of fatalities. Fortunately, there is no fatalities in this scenario. So also the number of people exposed to the shaking, and also the number of people are expected on average using the median shaking intensity. And also the results can be downloaded, the census tract level results can be downloaded and stored in the computer. So it took 1 minute to run this scenario. I can run another scenario somewhere else here, for example. So new simulation, I can choose another magnitude, 6.25, 6.5, and then I choose the average depth. And then again, run another scenario, 1-2 minutes. I see if the earthquake happens outside on the suburban area, what would be the losses? Where are the hotspots, the region that needs attention from the emergency manager and fire departments? So this kind of rapid analysis on the fly, it makes it easier for the emergency manager and public safety community to understand the risk. And once it's, for them, they have a clear picture or order of magnitude of this risk, they can later decide that they want to do more detailed, for example, site microzonation. They can go into consulting with the structural engineers and do scenarios with retrofitted building. So this is the main objective of the tool. So with this, I thank you very much. I think I took 10 minutes, right? Okay. So,
Any questions for Juan? Yeah.
In 1997, you know, there was a earthquake near Galaxy, and it's like about 1955.
yeah, it was.
You could use this kind of to compare your results.
Yeah, but yeah, we can do this right now, sure. But with the new expo, because building counts from 20 years ago are not the same, so the losses will be expected to increase. So this is also to see that the exposure has an effect on the, if a repetition of a historical event happens now, after 20, 30 years, your exposure is different. So this can be done quite rapidly. Just to quickly show you that you can also show the census tract statistics, so you can see what has been calculated, the ground shaking intensity, the normalized economic loss, the number of buildings for this specific census tract, and also the other elements. Thank you.
Any other questions? So something that we found where a tool like ER2 would be something that we found where a tool like ER2 could be very helpful is just building up a literacy of cause-effect relationships within the emergency management community. So people get a sense of an earthquake of this magnitude at this location could generate this level of impact. Also, for many emergency management communities who are developing scenario exercises, often they're looking for a level of impact to exercise their capacity to respond. So having the ability to choose different scenarios that have different levels of impact is something that's asked for within the emergency management community. So often they're not looking for the most likely or the most severe earthquake that occur or flood that could occur in a particular area, but they're looking for, could you build me a scenario that has these characteristics in terms of impacts, because we want to exercise our ability to respond. So this is a way of allowing that more fluent conversation between people that are generating the models and people who are using the models. So thank you very much for sharing this. Yeah.
Yeah, so like I have had this question for a while for other presentations about risks. So as far as I remember from one of the papers, like from global reports, more than 50% of the losses.
So is it the question for me or for me?
This can be related
okay.
to most of the presentations. So more than 50% of losses globally, I think, can be related to the structural damages, which is the primary effect of earthquakes. But we have secondary effects of earthquake, like liquefaction, landslide, tsunamis in cases like Southwest Vancouver. I've been wondering during these presentations, do we take into account any effect of these things and like these hazards or not? Like they were definitely pose some threat to the public and buildings, although they're secondary effect. And I think it is not negligible. Like at least I was 20 or 30% of global losses. There was a different USGS page I cited there. So I was wondering if you take into account this. If not, what?
Well, for right now, we don't consider the landslide liquefaction effects at the moment. But this is the first layer of information. The shaking intensity is the predominant based on statistical analysis of earthquake damage survey. But still, liquefaction, depending, for example, in New Zealand, this was one of the major causes of damage to houses. And also landslides, this is something should be considered. Sorry?
In Quebec, close to downtown, you have like an alley beside that river.
That's
and you have like, I think there's a lot of seismic play there. You get a lot of slides there without.
Yeah, potential. There is this also the clay layers, the the Bonita clay layers that are susceptible to landslides. So the idea is to have a platform, an app, a computational tool that is adaptable to add other layers of damage. So you can have the layer of landslide hazard. What is the susceptibility? What is the threshold shaking intensity to induce a landslide or liquefaction? And then you have fragility function that takes into account the big ground displacement, not the shaking intensity. So you need these three input parameters. Yeah. you want to add something?
Great, I see a lot of tired faces out there. Any other questions before we kind of formally wrap up? And again, thank you very much, Anna, for sharing research that you're doing.
If you have refresh the website for the workshop, now there is a new tab with the presentations. Still, all of them are not there, but you can, I will keep updating them as we have the time to say them. You have to refresh. Who is showing?
I don't know if it's,
Okay,
I'm
good.
not
Yeah,
really sure.
there you go. Presentation. So there are so far the ones related to Gem and OpenQuake, but later we will put all the slides for the natural resources work.
Great. Well, again, on behalf of the hosts, Western, ICOR, and Natural Resources Canada, and the Global Earthquake Model Foundation, again, thank you so much for giving us 2 days of your very valuable time, and we look forward to seeing you down the road. So take good care, travel safe, and we'll see you next time. And thanks everybody online.
Also, we are running right now, so if you want to keep running, answering the
Should I,
homework, there is some
you can
speakers
just
from
stop it.